All right, so previously we reviewed the continuous integration process, and now we're going to take a look at the continuous deployment process. We've kept the continuous deployment components in a separate repo, and this is going to demonstrate how code moves from the developer's local environment to a Kubernetes cluster with the assistance of ArgoCD. We'll take a quick look at the architecture at a high level before we continue. So if we take a look here, we see that the process will start with the code change in our CI repo. When code gets pushed to GitHub, it will trigger the CI pipeline to build and push the image. We also have a parallel security scanning repo. I've decided to keep that modular so it doesn't interfere with the build and deployment process, just for demonstration purposes. And to continue the CI process, the manifest is updated with the new tag that gets applied, and that new image will get placed into the deployment, the Kubernetes deployment. ArgoCD will recognize it, and it will get deployed to the cluster as the final stage. Okay, so the focus here will be on continuous deployment. This repo will be used in conjunction with the NCFTTX portal repo. Okay. Now, if you'd like to actually look at just the deployment process in isolation, just for validating and testing, we can actually just run the deployment piece in a sandbox environment, just so we can check out all the Kubernetes manifest files and see how the app is deployed. So we'll go ahead and do that first before we execute the entire process. All right, so as I mentioned earlier, ArgoCD lives inside the Kubernetes cluster itself. It's not just an external tool that watches from the outside. It actually has its own set of pods running within the Kubernetes ArgoCD namespace, and it reconciles what's going on in Git with the current state of the cluster. So it's a top-level manifest that tells ArgoCD how to manage everything. So if we look here at the metadata, we see that we have the name of the application that we're managing and the namespace that's going to be defined in the cluster, ArgoCD. And the finalizer section basically acts as a safety net that helps us clean up any resources in the event that the application gets removed from ArgoCD. Now, if we look at spec, source, and destination, think of this as where to read from and where to deploy to. So where are we reading from? We're reading from the CD repo. This is where all our manifest files are created. We're monitoring the head for any changes, so it tracks the latest commit, in other words. And the path for the manifest files is the manifest directory. Now, where are we deploying to? That's going to be the Kubernetes cluster that it resides on. So this right here refers to that cluster. And of course, we have the namespace for the application. Okay, now the sync policy section basically tells us how and when to sync. So if a resource is removed from Git, ArgoCD will automatically delete it from the cluster. That's what's meant by pruning. If a resource gets manually edited by kubectl, ArgoCD overrides it immediately to match Git. We also have the ability to create the namespace. So this is important because if the namespace isn't defined first, or if it's missing for some reason, we're giving ArgoCD the okay to create the namespace. In addition to that, we have our retry, which is known as our exponential backoff. So basically, on a sync attempt, if it fails, it's going to retry up to 5 times, and it's going to double that each time. So it'll go from 5 to 10 to 20, etc., up until the 3-minute threshold. Okay. Now, as far as the revision history limits are concerned, ArgoCD stores a record every time it syncs. Now, as you can imagine, we'd have a lot of records after a while, so it stores only the last 3 entries here. And of course, we can change that manually if we'd like to. Okay. Now we're going to go and look at some of the other manifest files. We can start off with namespace. That one's pretty straightforward. So basically, NCFTTX portal. This must match exactly what's in our application YAML that we looked at earlier. As you can see here, we're dealing with our local environment. This label flags the namespace it's running in the local environment, and it lets us know here underneath that it's managed by ArgoCD. So anyone who's looking through or trying to troubleshoot the cluster will see that this is in fact managed by ArgoCD. If we go here to the deployment manifest, okay, this is the real workhorse right here. We're defining an application, okay, that will have 2 replicas. We're going to use the rolling update feature. So basically, on a new image push, Kubernetes will start a new pod before killing the old one. That way we have very little downtime. And as far as rolling updates concerned, at most, 1 pod can be down with 1 extra pod up and running during that rollout period. Now, I purposely did not add a Prometheus YAML to this workflow. We can expand it earlier if we want to add monitoring to this. And if we do, we'll have all the code here necessary. We don't necessarily have to add it from scratch. So this is just kind of thinking forward. If we want to add monitoring to this stack, we have some of the code here. If we want to go down a little bit further, we can take a look at the resource limits. So think of this as like the memory and CPU boundaries in a sense. So basically, the guaranteed minimum resources that the scheduler is going to reserve for this particular pod is going to be in the request section. And in the limit section, this is like our hard cap. So basically, exceeding the memory that kills the pod. Okay, so this is the top level ceiling, and we can't exceed that or else it'll kill the pod. Okay, so memory, CPU, boundary limits. Security context. This is very important because we never want to run a container as a root user. That gives it way too many privileges. So we always want to make sure we use a non-root user. And one of the ways we can do that, both at the container level and at the pod level, is run as user 1000. Okay, so this runs the processes as a low-level user. UID is 1000, which is pretty standard for non-root user in most Linux images. Okay, so let's go down to service. Okay, now the service basically acts as the traffic controller. As you know, Kubernetes pods are ephemeral, so they can die instantly and come back with a new IP. So we need a stable endpoint, and that's where the services come into play. If you don't provide a service, Kubernetes will use cluster IP as the standard default service. We explicitly define cluster IP here, and we actually define the ports. So basically, the front door in which the clients connect to, the port is going to be 80, and the target port, this is the listening port for the container, that's going to be 880. Okay, so basically, these are all the files that are going to be tied to ArgoCD. These are the files that ArgoCD is going to observe and reconcile when we go ahead and start our deployment. Okay, so let's go ahead and go to the next section. In our previous video, we took a look at the ArgoCD manifest file. And before we demonstrate ArgoCD, we're going to set up our local environment. So I'm using the Docker desktop single node Kubernetes cluster. So I have that enabled here. And if we go back to VS Code, we can use kubectl version just to ensure that we have the kubectl command line available. Okay, and then what we're going to do is run kconfig current context. Okay, we just want to ensure that we're actually referencing the proper cluster, which is the Docker desktop cluster. Okay, so next what we want to do is make sure that we have the Helm chart for ArgoCD installed. Now, I actually already have the ArgoCD Helm chart, but I'm going to go through the steps just to demonstrate the process. Perfect, so we got the message that says already exists. That's to be expected. If we run Helm repo list, you can actually take a look at all of the Helm repos that I have currently in my local environment. And as you can see, ArgoCD is listed. Now, before we continue, we want to make sure that we have the correct namespace added. So I'm just going to run get namespace. And I want to make sure I have ArgoCD already named in my cluster. And I do. Okay, that's very important because for the next command, we're going to run the Helm template command right here. Okay, so this command is very granular because it lets you define the version number, the appropriate namespace for the template file or the template YAML that's going to have all of the information for our ArgoCD Helm manifest file. So I'm going to go ahead and hit enter. In just a couple moments, we'll have that file there. And then we can check out the pods for ArgoCD. Okay, so if I go to Helm, and I look here, I should see the template file. It's a very large file that's going to have all the resources and references we need for ArgoCD. Okay, I'm going to go ahead and close that, go back to the cluster, and we just want to take a look and see here. We just want to make sure that we have all the files applied first. Okay, in our previous video, we reviewed the ArgoCD manifest file. And before we demonstrate ArgoCD, we're going to set up our local environment using the Docker desktop provided single node cluster. As you can see here, I have it already enabled. So if we go back to VS Code, we're going to run kubectl version. We just want to make sure that kubectl is up and running. And then we're going to run kconfig current context. We want to make sure we're referencing the Docker desktop Kubernetes cluster, and we are. Now, I actually already have the ArgoCD Helm chart installed, but I'm going to show the command here that I would use. We'll get a message that says already exist, which is perfectly fine. And what I'm going to do now is just show all of the Helm charts that I have currently in my local environment. So I'm going to run Helm repo list. and we'll see in just a moment here that ArgoCD is already installed. Okay. Now, as a second check, what I'm going to do is make sure that I have the correct namespace. ArgoCD should run in the ArgoCD namespace. I want to make sure that's defined in my cluster first, and it is. Okay. So this will allow us to run the the ArgoCD template command. So what we're going to do is create a YAML template that will allow us to define all of our requirements first, such as the version number and the namespace. And then once this template file is created, we can run kubectl apply-f. Okay, so this will take a few moments here. Okay, so the template file was in fact created. If we were to go to the Helm directory, we can see that we actually have the file right here. It's a very large file that has all the required resources for ArgoCD. Next, what we're going to do here is run the kubectl apply-f file, and we need to make sure that we run it in the proper directory. As I just showed here, the Helm directory is where the file is located, so I'm going to run my kubectl apply-f command in the Helm directory, and we're going to point it to the template that we just created. Okay, that command is going to take a little while to run. That's completely normal. Now that we have ArgoCD up and running, what we can do is go ahead and check and see how the pod creation process is going. Okay, here we go. So what I'm going to do here is run a command that'll let me watch the pod creation, kubectl get pods in the appropriate namespace with the watch flag. And this should let us know how we are progressing. Okay, things are looking good so far. While this creates, I'm going to take another look at another command here. I'm going to run kget service in the namespace ArgoCD. There we go. Okay, here we go. So I wanted to make sure that the ArgoCD server is actually up and running because we're going to use our port forward command to access the internal ArgoCD server port. Okay, so as you can see, the ArgoCD server is running, and it has two active listening ports, port 80 and port 443. When we structure our port forward command, we want to make sure that we map to the secure port for HTTPS traffic. So I'm going to run another terminal instance, and I'm going to paste my port forward command. And as you can see, we're naming the appropriate service and mapping a browser port, which will be port 80 to 443, which is the listening port for the service. If I hit enter in just a few moments, perfect. So I'm going to open up another browser in a different window here. And I'm going to go ahead and go to the advanced commands. Okay, and I'm going to accept the risk and continue. And I should get access to the ArgoCD UI. Okay, perfect. Now, before we can proceed, we're going to need to make sure we obtain the credentials. So I'll go through those commands next. All right, so the command for the username and password secret is this right here. It's going to be ArgoCD get secret. And this is how we obtain the initial admin secret here. Okay. So what we're going to do here is take this base64 encoded password, and we're going to incorporate this into our decode command. So we're going to run echo. We're going to paste in the command, or excuse me, the encoded command, and then we're going to run base64-d. Perfect. All right. So Kubernetes is set up to have an username, a default username for admin, and we're just going to use this as our password. Okay, so I'm going to go back to the UI, and we're going to type in, we're going to type in admin, and we're going to go ahead and put in the password, and perfect. We have access to the ArgoCD UI. So once we run our pipeline, we'll be able to see the deployment in this window here shortly. Now that we've applied the application manifest for ArgoCD, we can quickly check and see if the application is in fact running. We're going to use kubectl get applications in the ArgoCD namespace. All right, so we have a healthy status. Now we're just going to take a look at the pods. All right, now we can take a look at the service. Okay, we can see that our application is running, and it's going to be on port 80. So when we construct our port forward command, we can make sure that we map our desired browser port to container listening port 80. So I'm going to bring up another instance of our terminal. Okay, now that we were able to run our port forward command, if we go to port 882 in our browser, we type in localhost 882, we should have access to our application, and we do. And if we go back to the ArgoCD UI, we can see in fact that our application is being tracked, and if we click here in this pane, we can see that the application itself consists of these three manifests that we saw earlier, the namespace, the service, and the deployment. And the particular deployment yields 2 pod replicas right here. So this basically lets us know the entire path to getting these applications up and running on the cluster. It lets us know the current status, it lets us know that it's synced, what commit, and it also lets us know when our last sync was. And if we click on one of these pods right here, we get some more granular information. So for example, we see the image and the particular hash that is being used on this particular container. And we can actually look at the entire manifest file. So this gives you a really good high-level and granular look at all the events that are taking place, including logs as well. Okay, so ArgoCD is a very helpful tool, and what we're going to do next is we're going to actually make a change to the application itself by editing the source code, and we're going to see if the application changes as a result. It should pick up the change, and ArgoCD should recognize it, and it should apply it in true CICD fashion. So if you look down here where it says 2025 North Carolina FTTX portal, we're going to change that in the index file in the application source code, and then we're just going to let the pipeline run and see what happens. Okay, so we're going to go ahead and go back to the terminal. Okay, so I've returned to the terminal, and I went ahead and accessed the CI repo. That's the repository that has the application code and all of the web-based files, like our index file. The line that I mentioned earlier on the application, the one that has 2025 North Carolina FTTX permitting portal as the footer, we're going to go ahead and change that line of HTML code here, and we're going to make that 2026, and we're going to go ahead and save that as well. Okay. Now, if we run git status, okay, we should see the index file here as one of our changes, not yet changed for commit. And what we're going to do here is we're just going to run this in our git add command. So I'm going to run git add, and we're only going to add this single file here. Okay. and then we're going to run git commit. We'll make a brief commit message that says index page footer update. Okay. In just a moment, we'll go ahead and test out our pipeline here. Okay. Now we're going to run git push origin main. Okay, and the process is going to begin. So I'm going to return to the portal, and I'm going to go take a look at, here we go, the GitHub Actions portal in my GitHub page, and we can see that the index page footer update is listed at the top. Our build has started. If I click on the header here, we can see that the build is taking place right now in real time. We can watch the process play out. As you can see, the build and push stages are in progress. Okay, so we changed the index file. The application code change triggered the CICD pipeline. It's going to attempt to build a new container based off that change we made. That new image is going to be placed into Docker Hub registry, and then that individual hash, that unique hash, is going to be created as a result of that new image. And the pipeline is designed to replace the image that's currently in our Kubernetes manifest, our deployment manifest, and update it with this new image. Okay, so it looks like the job has in fact completed. Okay, so what we want to do next is we want to take a look at the unique hash. Okay. Okay, perfect. I just want to make sure that the job did in fact complete, and it did. Okay, now if we go to our other repo, let me go ahead and pull that up. Okay, here we go. So this is the containerized application image, okay, right here. And if we go ahead and look back at the manifest directory here, we should see, there we go. We should see that the file was updated about a minute ago. Okay, so it lets us know that the change was frequent, which is what we expected. And it let us know that approximately 1 minute ago there was a change made to our deployment YAML. And the change was, it updated the hash for our image. Okay, so our pipeline did exactly what it was supposed to do. And now what we're going to do is go and check the application code. Okay, so next we're going to check the application image in Docker Hub. Okay, so if we go to Docker Hub, let's go ahead and refresh real quick. All right, so we should notice that this new hash appears in our registry. We just want to confirm that the new image was delivered properly to the registry, and it was. Okay, so now we can go to the application itself. Okay, and we can refresh. Oh, almost forgot that we have to reinitialize our port forward command. Okay, here we go. Now if I go back to the application and I refresh, here we go, 2026. So our change was automated through the pipeline. And if we want to take a look at the ArgoCD UI, we can see that we have made a change here about 3 minutes ago. Now, this was our old deployment, okay? This was our updated deployment, which happened 3 minutes ago. These are the pod replicas in the deployment, and if we look a little bit closer, we can see that this was created about 3 minutes ago, and here's the hash that it referred to, okay? And just to really paint the picture, we can go back to the original deployment, and we can see that, in fact, the image is going to be a little bit different. Yes, there we go. So this is the old hash right here. And on the most recent deployment, we should see the new hash. There it is, right there. Okay. So ArgoCD recognized the change and did its job and applied it to the deployment, which is why we see it right here. Okay, so that's an example of the full CICD process from end to end.